65 million years ago, the Earth was a paradise of giants. Dinosaurs ruled every continent. Massive sauropods shook the ground with each step. Tyrannosaurus rex stalked through dense forests. Pterosaurs soared across skies thick with oxygen. The planet hummed with life in every form imaginable. Flowering plants had only recently appeared, splashing the landscape with color for the first time in Earth's history. Insects buzzed, small mammals scurried through underbrush, living in the shadows of giants. Everything seemed eternal, but on one particular day, a Tuesday perhaps, or a Thursday, though the dinosaurs didn't keep calendars, everything changed. Not gradually, not slowly, instantaneously. An asteroid roughly 6 miles wide was hurtling toward Earth at 45,000 miles per hour. It had traveled for eons through the cold darkness of space, a fragment of the early solar system that had somehow avoided being swept up into a planet. Its destination, the Yucatan Peninsula. Today, we're going deep into one of the most catastrophic events in the history of life on Earth. Not just the impact itself, which was unimaginably violent, but the hidden chain reaction it triggered. The cascade of disasters that followed. Because what killed the dinosaurs wasn't just a rock from space, it was what that rock did to the Earth's interconnected systems, the atmosphere, the oceans, the food chain, the climate itself. This is the story of the day the world ended, and the hidden mechanisms that made sure it stayed dead. The asteroid entered the atmosphere over the Gulf of Mexico on a shallow trajectory. For a few seconds, it became brighter than the sun itself. Every creature on the Yucatan Peninsula, every dinosaur, every insect, every plant, looked up at a light so intense it would have instantly blinded them. Then came the sound, a roar so loud it ruptured eardrums hundreds of miles away, but most creatures never heard it. Because the asteroid hit first. It excavated a crater over 100 miles wide. The crater still exists today, hidden beneath Mexico's Yucatan Peninsula, a scar called Chicxulub. From above, using gravity mapping, you can still see its perfect circular structure like a frozen ripple in the planet's skin. But here's where the chain reaction begins. The impact instantly vaporized trillions of tons of rock. Limestone, gypsum, granite, all of it transformed into superheated plasma and ejected into the atmosphere at thousands of miles per hour. This debris didn't just fall nearby, it was launched into space, above the atmosphere, where it briefly orbited Earth before raining back down across the entire planet as molten glass spherules. Imagine standing in what is now North Dakota. You're a small mammal, hiding in a burrow. The ground shakes. Minutes later, the sky begins to glow. Then it starts raining fire. Wildfires ignited simultaneously across entire continents. Forests that had stood for millions of years combusted in minutes. The thermal pulse alone cooked animals alive, even in the shade. And this was just the first hour. The Yucatan Peninsula had a hidden danger that made the impact exponentially worse. The bedrock was rich in gypsum, a mineral containing vast amounts of sulfur. When the asteroid struck, it vaporized this gypsum instantly, releasing roughly 300 billion tons of sulfur dioxide into the stratosphere. This is where the real killer emerged. Sulfur dioxide, when mixed with water vapor in the upper atmosphere, forms sulfuric acid, the same acid used in car batteries, the same acid that can dissolve metal. And now it was raining from the sky. The acid rain was strong enough to burn through vegetation. Lakes and rivers acidified. The pH of the ocean surface dropped dramatically. Creatures with calcium-based shells, ammonites, plankton, coral, began to dissolve alive in the water. But the sulfur did something even more insidious. It blocked out the sun. The sulfur particles formed a global aerosol layer in the stratosphere, a reflective blanket that bounced sunlight back into space. Within weeks, global temperatures plummeted. This wasn't a gradual cooling. This was an impact winter, a rapid, devastating freeze that dropped global temperatures by as much as 25 degrees Celsius in some regions. Dinosaurs that had survived the initial impact, the firestorms, the acid rain, they now faced something their biology was never designed for: cold. Photosynthesis stopped. It's hard to overstate how catastrophic this was. Photosynthesis is the foundation of nearly all life on Earth. Plants convert sunlight into energy. Herbivores eat plants. Carnivores eat herbivores. When the sun disappeared behind a veil of sulfur and ash, plants began to die within weeks. Ferns withered. Trees dropped their leaves and entered dormancy, but many never woke up. Herbivorous dinosaurs, massive creatures that needed hundreds of pounds of vegetation daily, starved first. A full-grown triceratops weighed 6 tons and required an enormous caloric intake just to survive. When the food disappeared, these giants had no reserves left. Their metabolisms, optimized for abundant resources, became death sentences. The herbivores died. Then the carnivores followed. Predators like Tyrannosaurus rex, already rare due to their position at the top of the food chain, found themselves in a world with no prey. Scavenging could only sustain them for so long. In the oceans, the collapse was even faster. Phytoplankton, microscopic organisms that form the base of the marine food chain, died en masse without sunlight. Within months, oceanic ecosystems unraveled, fish starved, marine reptiles like mosasaurs and plesiosaurs, apex predators of the Cretaceous seas, had nothing left to hunt. The oceans became graveyards, but some creatures survived. Small mammals with their lower metabolic needs could survive on seeds, roots, insects, and carrion. Birds, descendants of theropod dinosaurs, adapted quickly, their ability to fly allowing them to search vast areas for food. And deep in the ocean, away from the light-dependent surface ecosystems, life near hydrothermal vents continued uninterrupted. Down there, in the crushing darkness, chemosynthesis, not photosynthesis, powered life. The hidden chain reaction had a pattern. Size mattered. The largest creatures died first, the smallest inherited the Earth. The darkness lasted for years. Some estimates suggest sunlight was reduced by 90% for up to 2 years. In some regions, it may have been even longer. The planet existed in a twilight state, not quite night, but never day. Temperatures remained low. Ecosystems that had thrived for hundreds of millions of years simply stopped. The fossil record shows this moment with brutal clarity. There's a thin layer of rock, just a few centimeters thick in most places, that marks the boundary between the Cretaceous and Paleogene periods. Below this line, abundant dinosaur fossils. Above it, almost none. This boundary layer contains concentrations of iridium, an element rare on Earth but common in asteroids, at levels hundreds of times higher than normal. It's the fingerprint of the impact, preserved for eternity. Eventually, the skies cleared. Sulfur compounds settled out. Ash fell. The sun returned. But the world it illuminated was unrecognizable. 75% of all species on Earth went extinct. The dinosaurs, except for their bird descendants, were gone entirely. The marine reptiles, gone. The ammonites that had flourished for 300 million years, gone. The niches they left behind were empty, and into that emptiness stepped something new. Mammals. Small, adaptable, warm-blooded creatures that had lived in the shadows for 100 million years suddenly found themselves with space to grow. Within 10 million years, a blink of geological time, mammals diversified into thousands of new species: primates, ungulates, carnivores, whales. Eventually, us. The extinction of the dinosaurs wasn't just about a rock from space. It was about interconnection. The Earth is not a collection of separate systems. It's a single, interdependent web. Touch one thread, and the entire structure vibrates. The asteroid touched everything at once. Sulfur from deep rock became acid in the sky. Acid destroyed plants. Plants fed animals. Animals fed other animals. When the bottom fell out, the top collapsed instantly. This hidden chain reaction, this cascade, teaches us something profound about our own moment in history. We live in an interconnected system just as fragile as the Cretaceous world. Our atmosphere, our oceans, our food chains, they all depend on delicate balances. The dinosaurs didn't see it coming. We still can. 65 million years ago, the world ended for the giants, but life, stubborn, adaptable, relentless, found a way. It always does.